right now.
Are you ready?
Alright, the special case with this, Kevin, that we're going to be dealing with is, this says 15 degrees and 30 minutes. Alright, so remember, when we're dealing with this, and we're going to be, obviously using the law of sines, we're going to have to be plugging this into our calculator. We're going to want to convert this to a decimal form. So one thing to remember, when we have a degrees, and we have minutes, we're going to put that 15 degrees is going to be plus 30 over 60 minutes, right? And if we had seconds, that would be over 3,600 seconds. So when you do 30 over 60, you end up getting a decimal, that's 1/2, which is 0.5. So I end up, my decimal is going to be 15.5 degrees, as this would be like, 60, it takes 60 minutes to make 1 degree, so you have 30 out of the 60 degrees. Make sense? So if you have a minute, just make sure you put it over 60 minutes and add it. And remember, the one thing I also said is, let's say it looked like this, 15 minutes, 30 minutes, and 15 seconds. Just remember for that one, it'd be 30 over 60 plus 15 over 3,600, as there's 3,600 seconds in 1 hour. That's going to make a degree. So anyway, so we just had this. So I'm just going to rewrite this as 15.5 degrees. Now, since I'm given two side lengths, one is an opposing angle, and I have two side lengths and an opposing angle. That means CB and B, that's an opposing angle of a side length. Since I have that, I can use the law of sines. So the law of sines, remember, states A over sine of A equals B over sine of B equals C over sine of C. As these are, the lowercase are your side lengths of your triangle, uppercase are your angles. Let's just draw a quick little picture just to kind of get a little representation. I don't really know what this triangle looks like right now, but I'm just going to kind of make a makeshift triangle. So B is going to be 15.5 degrees, 6.8, A equals 4.5. So immediately I do not know what angle A is, and I can use that in my proportion to find angle A, or to find that angle A. So I'll say 4.5 over sine of A is equal to the ratio of B, since I know those values, which is 6.8 over the sine of 15.5. All right. So then what I'll do is I'll cross multiply, divide by 6.8. So what I get is sine of A equals 4.5 times the sine of 15.5, all divided by 6.8, right? When I kind of cross multiply and solve for sine of A. So let's plug this in our calculator. See what we get. 4.5 times sine of 15.5 divided by 6.8. And I get 0.1768, keeps on going on and on forever. You can write in that answer, but I prefer you just to keep it in your calculator when solving these, because 0.1768 is not going to be my angle. Remember, that's the sine of A equals 0.1768. So to figure out what my actual angle is, I'm going to have to use the inverse sine of that answer, or in my calculator, I'll just do second answer, which gives me 10.19, as I'm going to round to the 100th. So I could say A equals 10.19. All right, so now I know what A is, so I can just write 10.19. And therefore, to figure out C, I just take 180 minus 15.5 minus 10.19. And that's going to equal angle C, right? Because remember, all three angles add up to give you 180. So if you have two of them, you subtract them from 180 to get C.
Yeah.
So 180 minus 15.5 minus 10.19, and I get 154.31. Now, lastly, we just need to apply the law of sines again. Okay, we're doing this over and over and over again, and we're gonna get really, really good at it. So now I know that sine of C is 154 degrees. Well, so now I just need to figure out the value of C. Really, that boring?
Yes.
Right?
Not boring at all.
What was I doing? Okay. The next thing is you're going to want to choose, again, a ratio. Well, now I know that both values for A and I know both values for B. Just to make sure, in case I made up some small little rounding error or anything, even though I didn't round it, we're going to use my original ratio of B over B. So I'll do 6.8 over the sine of 15.5 equals C over the sine of 154.31. Therefore, C is going to equal 6.8 times sine of 154.31 divided by sine of 15.5. And sorry, my handwriting's really bad when I get down that low, but let's multiply this. 6.8 times the sine of 154.31. And then let's divide that by sine of 15.5. And I get 11.03. And does that kind of seem like it fits with my triangle? Yep. So there you go. That's how you use the law of sines, especially when you have a degrees with minutes. All right.
Did I answer?